it's called the Black Widow. Not because of its deadly bite, but because the main component of this directional antenna are 4 fiberglass fishing poles. Stay with me as we build a portable Moxon antenna for 15 meters.
Let's go.
But seriously, the Moxon can be a killer of an antenna on the upper bands, and it is not difficult of a project to put together. As we're climbing up the solar cycle, these types of antennas become more and more popular as their gain and excellent front-to-back ratio make them ideal for hunting DX or to pack a bit more punch into your signal. The Moxon is named after its creator, Les Moxon, G6XN. It is best described as a rectangular, 2-element Yagi antenna. I said rectangular, as the ends of the driven element and the reflector are folded inwards, which reduces the amount of space it occupies by about 30% as compared to a full-size dipole antenna. If you add lightweight spanners to this rectangle, you can easily rotate the antenna. Now, Moxons typically have about 2 dB of forward gain, and they also exhibit a high front-to-back ratio of up to 9 dB, depending on the height in the band. Moxons are easy to build and highly effective on 10, 6, and 2 meters. I've previously built a 6-meter Moxon and have plans for it on my website. Links to it are in the video description down below. But today, I'm going to take it a step further, and we're going to build a 15-meter Moxon antenna. The inspiration for this antenna came from an article in the May 2003 issue of QST magazine by Alan Baker, KG4JJH, titled The Black Widow, a portable 15-meter beam. The article and full plans are available on Alan's website. Being that it's 20 years old, some of the parts are no longer available or really hard to find, most notably these fiberglass fishing poles. So what I did is I adapted that article in a couple of regards. One, I found a source for fiberglass fishing poles. They're still the Black Widow poles. And also, instead of building the center hub out of wood, like the article showed you, I 3D printed mine. And what that does is this makes the project a little bit more accessible if you don't have a wood shop, but you do have access to a 3D printer. All of my 3D printed parts are available on Thingiverse if you want to build this project yourself. Let's get started with the 15-meter Moxon antenna. For parts, we will need 4 B&M Black Widow 10-foot fiberglass fishing poles, model number BW3RR, available at Walmart. 1 3D printed Moxon hub, 1 3D printed feed point center, 1 SO239 chassis connector, approximately 50 feet of wire. I'm using 14 gauge. A 5/8 inch dowel, 48 inches, 1/2 inch of CPVC tubing, number 6 by 1/2 inch machine screws, nuts, and washers, 4 number 10 eye hooks, epoxy glue, duct tape, and a painter's pole, 15 to 23 feet. Once the parts are assembled, we need to calculate the wire lengths for the antenna. I use the MoxGen calculator that can be found on the ac6la.com website. This is a small Windows program that will give you the wire lengths necessary for the antenna. There are online calculators too, but this program can also generate an easy NEC file, so you can do some additional modeling. This is handy if you want to visualize the takeoff angle and front-to-back ratio of your antenna. The key in building a wire antenna is to subtract some wire length for velocity factor. The velocity factor is the difference between the actual length and the electrical length of the wire, and it can throw off your resonant frequency slightly. To correct for the velocity factor, you will need to shorten the antenna a bit. For HF antennas, I like to cut the wire to actual size and then use the excess wire from the velocity calculations for tie-offs or to make minor corrections. With most PVC insulated wires, the velocity factor will be 96% or 4% shorter than actual length. Here's my dimensions of the antenna corrected for velocity factor. I'll cut the antenna to calculated length and then shorten it when I lay the rectangle out. After getting the wire segment put together, what I really wanted to do was visualize the size of the 15-meter Moxon antenna. So I set some garden stakes up in the backyard and stretched the entire thing out in the backyard. And this is going to be a big antenna. I'm glad I didn't decide to make a 20-meter version. Measuring things out in the backyard, everything looks good. So what I'm going to do next is I'm going to mark the corner pieces with just a little piece of tape, so that when I get the spreaders put together, I should just be able to transfer this from the ground to the spreaders that are will be on the hub, and we should be mostly complete with the antenna. Let's talk a little bit about the hub, because the hub is really an important part of this antenna. And this is the hub. I 3D printed this. The original plans that I'm basing this project on called for building the hub out of wood. I don't really have much of a wood shop. I could do it with the equipment I have, but then I decided, well, you know, it's relatively easy to mock something up like this in Tinkercad. So I just took the dimensions and scribed them over into Tinkercad, added some holes for the to attach the spreaders. There's a hole in the center. What I'm gonna do with this is I 3D printed this little female adapter for a painter's pole, so that I can put that into the hub, and then this can be screwed onto a painter's pole. This is designed, the way the hub is designed is 5/8-inch dowels are going to go into here, and then they're going to go about 3 inches in, and then the rest of the dowel, I got a 48-inch dowel. I'm going to cut into 4 12-inch pieces. The other 9 inches are going to stick out, and then the fishing rods will thread into the back onto that 9-inch section. A 5-inch dowel is a little bit small for the fishing rods, but 3/4-inch dowel is too big. So I decided that just to make everything fit, we're going to use a little bit of Gorilla Tape to kind of fill in the gaps, and then it should all sort of press fit into place. If you find this type of content interesting and you want to see more like it, please hit like and subscribe. That's my indicator to produce more of these types of videos. Thank you for your support. When you were looking at my hub, you were probably wondering what the 5th hole was. I had another hole on the side of the hub, and it's going to be for this piece of PVC right here. The center connector is kind of heavy, and it's really sagging the antenna. I kind of figured that would happen. So I'm going to add a piece of PVC here, and that'll add just a little bit of extra support for the center connector. What we'll be able to do is run the coax up and then over the hub, and then down the CPVC to the feed point of the antenna. After getting the spreaders mounted to the hub, I taped the elements to the spreaders. I just wanted to kind of get a feeling on how this entire antenna is going to sort of fit before I cut the tips of these fishing poles off and install some eye hooks. So it's definitely kind of a big antenna, a little bit of a wobbly antenna. I think it'll have a little bit more structure once we get the hooks in here and get them all properly adjusted. So let's get the tips cut off of these fishing poles, turn them into decent spreaders, and we'll finish up the project. But the big question is, how will this antenna perform? Well, I put it on the analyzer and I pretty much nailed my target frequency. I wanted an antenna that would work between 21 and 21.4, 50 megahertz with a center frequency of about 21.200 megahertz. I hit that target of 21.2 with the lowest SWR of about 1.2 to 1. And it was, the rest of the antenna was 1.5 to 1 or less across the entire 15-meter band. Now this was without any further tweaking. Now the SWR is probably going to change slightly when I get this mounted up 15, 20 feet, but I don't think it's going to be any worse than those numbers, and it can only get better. But does this antenna actually work? For a quick test, I did some test transmissions on Whisper. Whisper is a weak signal propagation reporter, and it is a good indicator of an antenna's potential performance. I pointed the antenna west because that direction is clear and did a few low power transmissions. I'd have to say that I'm pretty impressed. Looking at the map, you can see reports to the west and also behind the antenna to the east. The western signal reports were on average at least 3 dB stronger than the east. I think the antenna's low height in this test had a lot to do with the skewed report. Once I get it higher in the air, that front to back ratio will be much stronger. I also did an A-B comparison between the Moxon and the vertical. Averaging out the signal reports from 8 stations to the west of the antenna, I found the vertical had a signal strength of minus 13.125 dB and the Moxon of minus 9.375 dB. The Moxon was 3.75 dB stronger than the vertical antenna. But for a real-world test, you're going to have to wait until field day. I built this antenna to take advantage of the 15-meter band. Our club always deployed a 3-element beam for field day, and when the solar cycle was peaking, we'd get amazing contacts on the 15-meter band. I want to replicate that experience with an antenna that's lighter and easier to deploy. So stay tuned for my field day video in a couple of weeks to see how the Black Widow 15-meter Moxon antenna performed. As a reminder, build instructions and links are all in the video description down below. If you have any questions about the 15-meter Moxon, leave it in the comments. Otherwise, stay tuned for part 2. It's when we put that antenna on the air. I'm Michael, KB9VBR. Have a great day in 73.